After 45 years drifting through the abyss, Voyager 1, the most distant human-made object ever launched, did something that no one anticipated. It didn't physically turn around. It couldn't. But the data it sent back changed in a way that immediately made scientists pause. A pattern appeared where there should have been randomness. A repetition where there should have been noise. A structured distortion in a signal that had, for decades, remained steady, predictable, and almost mechanical in its consistency. At first, it was dismissed as instrument degradation. Voyager is ancient by modern technological standards, built in the late 1970s with systems never designed to survive this long. But this was different. The anomaly wasn't degradation. It was coherence. And coherence, in deep space telemetry, is never ignored for long. Voyager 1 and Voyager 2 were launched in 1977 with a mission that was expected to last only a handful of years. Their primary task was to study the outer planets: Jupiter, Saturn, Uranus, Neptune. After that, they were expected to go silent, forgotten relics drifting into darkness. Instead, they survived everything. They crossed planetary orbits, survived radiation belts, endured decades of thermal stress, and continued transmitting data across distances so vast that even light takes hours to travel between them and Earth. Each spacecraft carries less computing power than a basic calculator today. Their memory is measured in kilobytes. And yet, they executed gravitational slingshots with precision that still baffles engineers who revisit the original mission data. Over time, systems were shut down one by one. Cameras. Heaters. Non-essential instruments. Not because they failed, but because power ran out. Each shutdown was treated like a farewell. And still, Voyager kept speaking. Then came the boundary event. Scientists had long theorized about the heliopause, the region where the sun's solar wind loses dominance and interstellar space begins. It was assumed to be a relatively smooth transition, a kind of fading edge. Voyager 1 crossed it in 2012 at roughly 120 astronomical units from Earth. But what it encountered there did not match predictions. Magnetic field measurements didn't behave as expected. Particle density increased, as anticipated, but field direction remained oddly stable. The transition was not chaotic or turbulent in the way models predicted. It was structured. Voyager 2 later confirmed the same pattern. Two independent datasets, two separate trajectories, one shared contradiction. Space beyond the heliopause was not behaving as empty interstellar medium should. Instead of randomness, there were patterns. Instead of chaos, there was alignment. Instead of silence, there was interference. For years, this discrepancy was studied and debated. Adjustments were made to heliophysics models. New simulations were run. But nothing fully resolved the inconsistency. Then, in early 2024, Voyager 1 sent something unexpected. Not a failure report. Not a clean data stream. But a distorted sequence of telemetry that repeated in structured cycles. At first glance, it looked like memory corruption. Bits flipping, packets repeating, systems misfiring. But deeper analysis revealed something unsettling: the repetition was not random. It followed a structured rhythm. A loop. A reflection pattern embedded inside the signal itself. Even more disturbing, backup systems, those not originally designed to transmit in that mode, began echoing the same pattern. It was as if the spacecraft was no longer just sending data, but participating in a feedback loop it did not initiate. One engineer described it, off record, as a signal that feels like it's being answered. That phrase spread quietly through internal discussions. Because if Voyager was being answered, then something had to be listening. Scientists began mapping the anomalies against cosmic conditions, solar wind fluctuations, galactic radiation spikes, and interstellar plasma density shifts. A correlation emerged. The distortion aligned with a sudden change in cosmic ray behavior, particles behaving in ways that defied heliospheric shielding models. It was as if the boundary itself had become unstable. Or worse, responsive. Magnetic field data added another layer of concern. Instead of smooth transitions, Voyager recorded localized distortions, twists and directional shifts that resembled interference patterns. Not random turbulence. Structured deformation. Something was shaping the environment. Not dramatically. Not visibly. But precisely. As Voyager continued its path, both spacecraft began exhibiting synchronized irregularities despite being separated by vast distances. Small timing shifts. Radiation fluctuations. Subtle alignment changes in magnetic readings. Statistically, this should have been impossible. Unless both spacecraft were interacting with the same large-scale structure. This led to a new and unsettling hypothesis. The Voyagers were not encountering separate regions of space, but a single, vast boundary system. Not a wall in the physical sense, but a layer of physics that behaves differently depending on scale and interaction. Some researchers described it as a membrane. Others avoided terminology altogether. A few quietly suggested something more extreme, that space itself may not be uniform beyond a certain point, and Voyager had entered a region where laws begin to shift. Then came the most controversial interpretation. The signal distortions were not random interference. They were structured reflections. Meaning information was not just traveling outward from Earth. It was returning, altered. As if processed. As if examined. NASA's public response remained cautious. Official statements referenced instrument anomalies and data degradation consistent with long-duration missions, but internally, teams were reassigned. Data access was restricted. Signal archives were reprocessed under stricter classification. The conversation moved out of public science and into controlled review environments. Meanwhile, theoretical models began to stretch beyond comfort. One proposal suggested Voyager had entered a region of spacetime where information loops are possible, where signals can reflect not just off matter, but off structure itself. Another suggested gravitational anomalies might indicate unknown mass distributions not visible through current detection methods. A more radical idea proposed that Voyager had crossed into a boundary layer between causal frameworks, where cause and effect behave differently depending on direction of observation. These ideas were not accepted. But they were not dismissed either. Because the data refused to fit anything else. Then came a synchronized event. Both Voyager 1 and Voyager 2 registered identical micro-fluctuations in signal timing within a narrow observational window. Separated by millions of kilometers. Identical response curves. This should not occur under any known physical interaction model. Unless the interaction source was not localized. Unless it was global, or larger. This raised an uncomfortable possibility. The Voyagers were not individually encountering anomalies. They were inside something. A structure vast enough to encompass multiple trajectories simultaneously. And if that structure existed, then so might a center. A source. Something that might be aware of every interaction within it. As analysis deepened, something unexpected emerged from the noise. Structured oscillations embedded within the signal distortions. Not language. Not code in a human sense. But repetition with constraint. Bounded variability. Mathematical consistency. Patterns resembling communication protocols but not derived from any known human system. At this point, interpretations diverged sharply. Some insisted it was instrumental feedback corruption amplified by extreme distance and system aging. Others argued it resembled emergent order in chaotic systems. A few quietly entertained the most unsettling interpretation of all: that Voyager had not merely crossed a boundary. It had been noticed. And the signal distortion was not interference. It was interaction. Over time, even cautious researchers began to acknowledge a shift in language inside internal discussions. Voyager was no longer described as simply transmitting. It was responding. The distinction, though subtle, changed everything. Because response implies context. And context implies awareness. Still, no direct evidence of intelligence was confirmed. Only patterns. Only structure emerging from noise. Only behavior that refused to remain random. And then came the silence within the silence. A period where data continued, but anomalies paused. As if something had stopped reacting. Or had finished observing. During that interval, trajectory models showed minute deviations again, subtle corrections too small for propulsion, too precise for drift. A controlled adjustment without visible cause. Not dramatic. Not obvious. But intentional in mathematical consistency. At this stage, even the most conservative interpretations began to shift. Not toward conclusions, but toward caution. Because whatever Voyager had encountered, it was not behaving like empty space. It was behaving like a system. A system that reacts. A system that records. A system that possibly remembers. And somewhere inside that system, Voyager 1 continues to drift. Silent in the way only deep space can be silent, still transmitting data that no longer feels entirely passive. Data that no longer feels entirely ours. And now the question is no longer whether Voyager crossed the heliopause. The question is whether, when it did, something crossed back. Not physically, but in signal.